You're most welcome in this lecture series. I'm Professor Dr. V.K. Gupta from Scope Global Skills University, Bhopal. Dear friend, in previous lectures, we discussed about rank determination, nullity, elementary row and column operation, and application of these elementary operations to determine inverse of matrices. Today, we will discuss a very important topic on matrix theory, that is determination of eigenvalues and eigenvectors. In the first part of this lecture, we will discuss about what is eigenvalues and how we will determine these eigenvalues, which are most applicable not only in mathematics but also in engineering, physics, as well as chemistry and other allied sciences. Dear friends, let us try to understand कि if we have any square matrix, for example, let A is any square matrix and its order is n by n, or simply we can say order of this matrix is n. Second, we have identity or unit matrix of the same order, that means of order n by n. And third, if we have a non-zero scalar quantity, here I am representing this by lambda. Remember that this lambda is a non-zero quantity. Then we can construct a new type of matrix with the help of A, I and lambda in the form of A minus lambda I by using simple algebraic operation on matrix, that means matrix A minus identity matrix multiplied by scalar quantity lambda. Then we get another matrix which is subtracted from A. Finally, we get again a matrix. This matrix is known as characteristic matrix, and its determinant value, that means determinant of A minus lambda I, is known as characteristic polynomial. This matrix is characteristic matrix, whereas this determinant of A minus lambda I is known as characteristic polynomial. And if we write this thing in the form of equation, that means whenever this polynomial is to be equated with 0, then we get an equation, a form of an equation. That equation is known as characteristic equation. So finally, in this way, with the help of given matrix, given square matrix A, identity matrix of the same order, that means of order n, I, and non-zero scalar, we are able to find an equation in the form of determinant of A minus lambda I is equal to 0. This is characteristic equation of this given matrix A. And whenever we solve this equation, because this characteristic equation is actually in terms of an equation in terms of lambda. And whenever we solve this characteristic equation, that means that equation in term which is written in the form of lambda, for values of lambda, those values of lambda are known as eigenvalues, as well as also known as characteristic values or latent values or spectral values. and these values are more applicable in allied sciences, and also for discussion of our determination of next thing of this chapter, that is eigenvector. So first of all, let's try to understand how we can determine any eigenvalue of any matrix. Firstly, I am considering here very small problem of matrix of order 2, that is, let us consider a matrix of order 2, that means 2 by 2 is 5, 4, and elements of second row is 1 and 2. You can see the order of this matrix is 2 by 2, that means it contains 2 rows and 2 columns. First of all, we will find out its characteristic equation directly. So, I am writing here its CH insert characteristic equation, which is determinant of A minus lambda I. Here, if we subtract leading element only by lambda. Remember, we have to subtract all the leading element which are given in the on the diagonal position by lambda, like this. Sorry, 2 minus lambda. Only elements on diagonal position. Now, this is a determinant. Now, determinant of order 2, to determine or to calculate the value of this determinant, if we use simple solution method of determinant of 2 by 2, for this, on crossword multiplication of these elements which are given on the diagonal position, that means 5 minus lambda is to be multiplied by 2 minus lambda minus 4 multiplied by 1, that is 4. After opening these brackets, that means by cross multiplication, we get 10 minus 5 lambda minus 2 lambda plus lambda square minus 4, which is equal to 0. And if we arrange this equation in standard form of the polynomial, we get lambda square minus 5 lambda and minus 2 lambda becomes minus 7 lambda. This 10 and minus 4 is plus 6 is equal to 0. So, in this way, we get this equation represented by lambda square minus 7 lambda plus 6 is equal to 0 is related to a respective characteristic equation for this matrix A. Let us consider this is our equation number 1, because we had to use this equation in forthcoming lecture for calculation of different things. Now, if we solve this equation to determine the value of lambda, that means we have to solve this equation for values of lambda. We can see very easily that this is the quadratic equation, can be solved either with the help of formula or by factorization. For factorization, let us consider lambda square, and on splitting of middle term, this can be written as minus lambda plus 6 lambda plus 6 is equal to 0. We have to split out this middle term such that कि splitted part after summation gives the same thing, -1 and -6 is -7, and the multiplication of these coefficient of these two terms, that means -1 whenever multiplied by -6 becomes the multiplication of first coefficient and last coefficient, that means 1 and 6. Now, if we consider lambda common from this portion, we get lambda into lambda -1, and -6 common from this portion, -6 and lambda -1, which is equal to 0, and we get lambda -1 and lambda -6 is equal to 0, or lambda is equal to 1 and 6. These are our required eigenvalues. We can check our answer by using the logic that the sum of these eigenvalues is always equal to the sum of elements on the leading diagonal position of given square matrix. दिए गए स्क्वायर मैट्रिक्स के डायगोनल पोजीशन में जो एलिमेंट्स हैं इनका एडिशन और इन आइगन वैल्यूज का सम या एडिशन दोनों आपस में बराबर होते हैं, विच इज 5 + 2 is 7, and here you can see 6 + 1 is 7. That's why our answer is correct. Now let us consider second type of problem, which is of large order than this. Here we had considered second order matrix, that means matrix of order 2 by 2. Now we will consider another problem which is more applicable. Normally we have to utilize matrix of order 3 by 3, most frequently in some other cases. For this, let us consider example. If A is of element 3, -4, 4, 1, -2, 4, 1, -1, 3. This is the matrix of order 3 by 3. And if we construct its characteristic equation, that means determinant of A minus lambda I, which can be written in the form of determinant of 3 minus lambda minus 4, 4, 1 minus 2, 4, then 1 minus 1, 3 is equal to 0 is required characteristic equation with respect to this given matrix A. Now, if we simplify this matrix, this equation, which contains a determinant of order 3 by 3, for this we will utilize simple expansion method to solve determinant. To solve this type of determinant, we will multiply leading element, which is here 3 minus lambda, after ignoring the row and respective column. That means we are considering here 3 minus lambda, but not considering the element with respect to the same row, that means first row and first column. For this, let us consider 3 minus lambda is to be multiplied by the elements of 3 minus lambda and minus 2 lambda, 2 minus lambda. is equal to 0. Now, let us consider this element 3 minus lambda. With respect to this, we will use this subdeterminant of minus 2 minus lambda and 4, and another row minus 1 and 3 minus lambda. So, by multiplication, 3 minus lambda is to be multiplied by the element minus 2 minus lambda with 3 minus lambda. I am writing as it is, minus 2 minus lambda is to be multiplied by 3 minus lambda, and minus, that means subtracted from minus 1, this is to be multiplied by 4. You know very well that this is crossword multiplication procedure. So, 4 whenever multiplied by minus 1 becomes minus 4, and this minus finally it becomes plus 4. Then after that, second element, that means element with respect to minus 4 is minus 4, and minus becomes plus 4, and it is multiplied by 1 multiplied by 3 minus lambda minus 4 multiplied by 1, that is 4, and similarly with respect to the third element on a leading row, that means on first row, plus 4 with respect to multiplied by 1 by minus 1 is minus 1, minus 2 minus lambda multiplied by 1 is minus 2 minus lambda, and after that this is equal to 0. Now, this 3 minus lambda as it is, after opening the brackets, minus 2 multiplied by every element of this bracket, that means 3 minus lambda, minus 2 multiplied by 3 minus 6, minus 2 multiplied by minus lambda plus 2 lambda. Now, minus lambda is to be multiplied with the every element of this bracket, means minus lambda with 3 is minus 3 lambda, minus lambda multiplied by minus lambda becomes plus lambda square, and remaining element is 4. Plus 4 multiplied by opening the bracket in this second bracket, 3 minus lambda minus 4 plus again 4 multiplied by, now open the bracket of this curly bracket, minus 1 minus, and this minus becomes plus 2, similarly minus, and this minus becomes plus lambda, and finally it is equal to 0. Now, we simplify this thing, 3 minus lambda. Firstly, I am writing here lambda square to write this expression in the standard form of polynomial from higher order to least order. Plus 2 minus 2 is minus lambda, plus 2 lambda minus 3 lambda is minus lambda, and minus 6 plus 4 is minus 2 plus 4, 3 minus 4 is minus 1, that is why we get minus lambda minus 1, and plus 4, and here that means minus 1 plus 2 plus lambda becomes lambda plus 1 is equal to 0. Now, we have to simplify and rearrange all the elements or all the quantities inside the brackets, we will observe that expression which is given in the form of lambda square minus lambda minus 2 is factorizable, and second, minus 1 can be taken as common from this bracket. So, we get plus 4 which becomes minus 4 after taking minus sign common from this bracket, and remaining we have lambda plus 1, and 4 multiplied by lambda plus 1 which is equal to 0. This, now we will arrange this thing, which is 3 minus lambda multiplied by lambda square minus lambda minus 2. Dear friends, just see here, this is minus 4 multiplied by lambda plus 1 plus 4 multiplied by lambda plus 1 will cancelled out. Now finally we get 3 minus lambda multiplied by lambda square minus lambda minus 2 is equal to 0, or 3 minus lambda. Now splitting out middle term of this expression, we can write this thing as lambda square and minus 1 plus 2 lambda minus 2, because minus 1 multiplied by 2 is minus 2 and minus 1, this is plus 1 and minus 2. Then we get plus 1 minus 2 is minus 1. Now 3 minus lambda, if we consider here, this is as lambda common element, we get lambda plus 1, and here if we consider minus 2 as common, we get again lambda plus 1 which is equal to 0, and finally in both the section we have lambda plus 1 as a common factor. That's why if we take out this lambda plus 1 as common factor, finally we get only two factors. First is lambda plus 1 and second is lambda minus 2. So, in this way we get three factors. First is minus 3 minus 3 minus lambda, second factor is lambda minus 2, and third factor is lambda plus 1. That means 3 minus lambda, this factor, lambda minus 2 and lambda plus 1 which are equal to 0. On equating these factors separately with the 0, we get three different values, three values of lambdas. That means lambda is equal to 3 by this, lambda is equal to 2 by this factor, and lambda is equal to minus 1 by this factor. So, in this way we get three eigenvalues of this square matrix, 3, 2 and minus 1. If you recall, our given matrix, which was matrix A of element 3 minus 4, 4, 1 minus 2, 4 and 1 minus 1, 3. After addition of all the elements which are given in the diagonal position of this given matrix, means 3 plus 3 is 6, minus 2 is 4. This is sum of elements on leading diagonal position of given matrix, one thing, and secondly, the sum of all eigenvalues. 3 plus 2 is 5 and 5 minus 1 is 4. That means our answer is correct. This is checking procedure whether our required eigenvalues are correct or not. Means sum of all eigenvalues must be equal to the sum of all elements on leading diagonal position of given matrix. So, in this way, this was the discussion on the method to determine eigenvalues of any matrix and followed by the illustration of this method to determine eigenvalues of matrix of order 2 as well as matrix of order 3. Now, we will utilize all these things, that means information about the method to determine the eigenvalue in our forthcoming lecture, in which we will determine and discuss methods to determine eigenvectors. Till then, goodbye.